Okay, so now we're going to develop something really important. It's called the law of sines. It's so important, it's a law, so you know it has to be good. Okay? The law of sines is going to help us relate the lengths of a triangle to the sine of the angles of the triangle. Okay? So we're going to kind of go through quickly a brief partial proof of how the law of sines is derived, and then we're going to spend some time working with the law of sines. Okay? In order to use the law of sines, we have a general oblique triangle, meaning any non-right triangle. We're not going to make any assumptions about the lengths of my sides or the size of my angles. All I know is that A, B, and C are not right. Other than that, they could be anything. I've drawn them acute, but this argument also will work if one of these angles is obtuse. Okay? All right, so to develop the law of sines, what we're going to do is I'm going to drop in a perpendicular line from angle B. Okay? So I've dropped in, that's I think really hard to see, a perpendicular line straight down from B. Notice that that forms a right angle. That's going to be pretty handy because now we can kind of think about splitting our big triangle ABC into two little triangles, this triangle and this triangle. Now, what else should we do with our triangle? Well, we should probably do some labeling. Okay, so our big triangle ABC, I'm going to label the sides, and in general, it's common practice to label sides opposite angles by the same letter. So here's angle A, so I'm going to call this side like little a. C, I'm going to call the opposite side little c, and B, I'm going to call this whole side little b. Okay. Now, what we want to do is we want to think about what information do we know based on our right triangle trig, because now we have two right triangles hiding inside of there. So let's focus for a minute on, excuse me, angle A. Okay. So when we're looking at angle A and trying to do some right triangle trig, we're going to focus on this small triangle here. Okay. So we're looking at this little triangle right here. It's a right triangle, which means we can say something about sine of angle A. We know that sine is what? Opposite over hypotenuse. So here's angle A. Our opposite is going to be this side. Maybe I should give that a label. I'm going to call it uncreatively H because it's a height. Okay, so opposite height, opposite height, or H over hypotenuse. Here's the hypotenuse. So sine of A, opposite over hypotenuse, is H over C. Another way of writing that is if I multiply both sides of this equation by C, I'll have C times sine of A equals H. Now, let's do something really similar, but we're going to look at angle C. Okay? So now we're going to think about angle C. If we're trying to do right triangle trig, that means we're focusing on the second right triangle that was created when we dropped in this vertical perpendicular line. Okay? And let's think about what we know about sine of C. Well, again, sine of C is opposite over hypotenuse. In this case, the opposite is still H. Hypotenuse is A, so sine of C is equal to H over A. Solving this, or getting rid of the fraction by multiplying both sides by A, gives me A sine of C equals H. Okay. Now notice, in this triangle, H doesn't change, right? If we're thinking about this little triangle or this little triangle, green or purple, our value, our length H is the same. In other words, this H and this H are exactly the same. That means I can equate these two equations because they're both equal to H. In other words, I can write C sine of A has to equal A sine of C. All right, well, that's interesting, right? A little bit of moving stuff around. In other words, if I divide both sides of this equation by A, and at the same time divide both sides of this equation by C, what does that give me? Well, C over C cancels, and on this side, I'm going to be left with sine of A over A. Over here, my A's cancel, and I'll be left with sine of C over C. So we have this nice ratio that says sine of A over A is equal to sine of C over C. That's pretty cool. Now, with a little bit of moving our triangle around, we can do something really similar. So now what I'm going to do is I'm going to rotate my triangle. So I took my original triangle and I rotated it. So angle A is now at the top. And I'm going to now do the exact same thing that we did before. I'm going to drop in a perpendicular line. So notice that that now forms two right triangles inside of this triangle. This one on the right and this one on the left. Okay, I'm going to call the length of that guy D, just so I don't get it confused, because it's certainly not the same as H, even though I formed it in the same way. It's not going to have the same length. I again forgot to label the sides of my triangle. Here's angle A, that means this whole side has, we're going to call A. Here's angle C, that means this guy is little c. Here's angle B, opposite him is going to be little b. Okay, now we're going to play the exact same game that we did before. Okay, all right. So let's look at this right triangle here. This right triangle here, if I want to think about the sine of C, well, sine of C is opposite over hypotenuse. In this case, sine of C is going to be D over B, which means if I move my B over, I get B sine of C equals D. Now we're going to look at the other little triangle inside that, the other little right triangle in here, this guy. Okay. And I'm going to think about sine of B. So well, sine of B is, again, opposite over hypotenuse. My opposite is D, my hypotenuse is C. So that's going to look like D over C, which if I solve by, or not solve, but move the C to the other side, I get C sine of B equals D. Now, just like we did before, this D and this D are equal, which means I can equate these two equations. B sine of C, let's use my color coded, might as well. B sine of C has to equal C sine of B. So many letters. Okay, all right. Well, again, if I do a little bit of rewriting, I can move this C over and this B over to get, it's not a chair, sine of C over C equals sine of B over little b, B. Okay. Well, if sine of A over A equals sine of C over C, and sine of C over C equals sine of B over B, really, I can write one giant equation that says sine of A over A equals sine of C over C equals sine of B over B. This is the law of sines. The law of sines lets us relate the sides of a triangle. Oh man, I messed up. Like just a tiny little mess up here, but I'm looking at it. I don't like it. This A should really be a little a, right? If it's a big A, it makes it seem like it's an angle, and that's not what this is. Notice up here I divided by little a. I just screwed up when I wrote big A here. Law of sine says sine of big angle A divided by little side A equals sine of big angle C divided by little side C, sine of big angle B divided by little angle B. This makes a whole bunch of ratios relating the angles of a triangle A, B, and C to the side lengths A, B, and C. Okay? This is hugely powerful, and it turns out we can use it to solve lots of stuff. Okay? So now let's go ahead and look at a couple of examples using this law of sines. Okay, so this is our law of sines. Sine of A over A equals sine of B over B equals sine of C over C. Okay? I've also put up here on the side kind of our different types of triangle. Side, angle, side, angle, side, angle, side, 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 angle, angle, side, side, angle. Okay? So remember, if we know any three pieces of information, as long as one of those pieces is a side length, we should be able to solve this triangle. We're going to work our way through as we go through the whole series of videos for this week and make sure that we've worked an example of each one of those. Okay? All right, so first, what do we have here? Well, we know a side and two angles. Let's sketch a quick picture to make sure we know which sort of flavor this is. Now, when we're sketching pictures, your book is always like, be careful to kind of sketch this to scale. I say, you don't necessarily have to worry about sketching to scale, as long as you're willing to realize that your angles may not look like they're supposed to. What is really important is to make sure that when I'm labeling A, B, and C, that I appropriately label the other side. So side A is opposite angle A, side B is opposite angle B, side C is opposite angle C. Now let's look at what we know. We know that side A has length 11. We know that angle A is 110 degrees, and we know that angle B is 20 degrees. Okay. So which one of these cases are we in? Well, we know two angles and a side. Two angles in a side, our choices are here, angle, side, angle, or side, angle, angle. But notice, with angle, side, angle, we know the side that's between our two angles. Is that the case here? No, the side between our two angles is C. We don't know C. So we're in side, angle, angle. And if I read this way, side, angle, angle, we can see that. So this is an example of side, angle, angle. I'm just going to write that here. Okay. Now remember that to solve a triangle, that means finding all three side lengths and all three angles. Well, one of these is really easy, right? I claim that we can find the last angle on this triangle, C, really simply. How can we easily calculate C? Well, by remembering that the angles of a triangle sum to 180 degrees. So if I have 110 plus 20, that plus C, that must equal 180 degrees. 110 plus 20 is 130. Well, 130 plus something must equal 180. That means C must be 50 degrees, since 130 plus 50. Okay, so now we know our C is 50 degrees. We're like a third of the way through solving for the things we didn't know. Now we want to solve, for side C and side B, but we can use our law of sines to do that. Okay. What does our law of sines say? Well, it says that the sine of A, which in this case would be sine of 110, the sine of 110 degrees, over side length A, 11, has to equal sine of, for example, B. Well, sine of B is 20 degrees, so sine of 20 degrees over side length B. That's something that we don't know. Okay, and that also has to equal sine of our C, which we decided was 50 degrees, over side length C, which we don't know. Okay, we can now solve for all of these unknowns. If we start here, sine of 110 over 11 equals sine of 20 over B. The only thing we don't know in that equation is little b here. So we can easily solve for little b. Now for these, we are definitely going to be using calculator approximations, okay? So if I'm gonna solve this for b, I can go ahead and approximate now, sine of 110 over 11. I can get a decimal approximation for that. I can get a decimal approximation for sine of 20. I'm going to go ahead and do this all as one step so that we can then enter it into the calculator together on the computer. So if I'm going to solve for b, I would multiply both sides by b. That would give me b times sine of 110 over 11 equals sine of 20. To get b by itself, I need to divide by sine of 110 over 11. That's the same thing as multiplying by 11 and then dividing by sine of 110. So I can think of this as 11 sine of 20 degrees over sine of 110 degrees. Okay. Now let's go ahead and enter that together into our calculator. So I'm going to switch over to calculator view here. Maybe. Okay, I'm going to go ahead and do a quick check. I'm in degrees. Yep, this guy's in degrees. Good to go. Okay, so we had 11, and I'm just going to put an extra parentheses. These shouldn't be necessary by order of operations, but I like to err on the side of caution. So 11 sine of 20 degrees divided by sine of 110 degrees. And I get 4.0036. Now in general, this is going to tell me what to round to. Let's go ahead and round to the nearest thousandths. So tenths, hundredths, thousandths. So we're rounding to this decimal place. This 6 makes this round up. So that tells me that our B is 4.004 approximately. So B is 4.004. I don't know why this chair insists on coming in. It wants you to see it. Okay. So now we've solved for B. B was 4.004. Last, we have to solve for C. Now, one thing that they often tell us when we're solving triangles is you want to use the things that you are originally given rather than intermediary things. What does that mean? We've actually done some rounding here for B, right? B had a lot more decimal points. So when I go to use my law of sines, it's recommended that I use this guy, which is kind of my original, sine of 110 over 11. Those were both given to me in the problem, and set that equal to sine of 50 over C. Okay? So if we do that, let me get this chair to not come back into the picture. We'll have sine of 110 over 11 equals sine of 50 over C. We're now going to solve this for C. Real similar to what I did before. If I multiply both sides by C, I'll have C times sine of 110 over 11 equals sine of 50. And then solving this for C by dividing by 110 over 11 really means I'm multiplying by 11, that 11 is in the bottom, and dividing by 110. So I'll have 11 sine of 50 degrees divided by sine of 110 degrees. And again, let's go ahead and together put that in our calculator. So we'll have 11 sine of 50 divided by sine of 110. Then we get 8.967. We were rounding to the nearest thousandth. So that's this place. That 2 means it's not going to round up. So we get that our C is approximately 8.967. So our C is 8.967. And there we have fully solved this triangle. We now know what all of the sides and all of the angles are. We did that using our law of sines, and that was an example of side, angle, angle. I'm gonna check that off on our little list here, because we've done an example of that type of triangle.